So now that we've gotten to a protocell, which like we said is just some membranes with enzymes inside of it, how did that actually transform into something self-sustaining that we can call a cell? Think about it. If we want to have a cell be able to carry out all of the properties of life and replicate on its own, which is one of them, we have to have the central dogma in place. We have to have the DNA to RNA to protein. We need to have the genetic code, which changes to RNA and then becomes a protein. We need to be able to pass that on. So it's kind of an argument of which came first, protein or DNA. So the RNA First Hypothesis says that RNA was the first one. We talked about this with the polymers as well. We have the evidence such that ribozymes are enzymes. So in theory, RNA can do the job of storing genetic information and acting as a protein. So it makes sense that that might have came first because it could do two jobs. We wouldn't need two molecules, it could do both of them at the same time. Then there's the fact that viruses only have RNA. So maybe the reason that they only have RNA is because they evolved so long ago and RNA came first and they just never took it a step further and got to DNA. That's a possibility. And it is possible that living cells started off with RNA and that they used reverse transcriptase. Remember what that means? It's transcribing but backwards, so going from RNA to DNA, and that's how DNA eventually came up. So we start off with this RNA and it gets transformed into protein because that's what RNA does, and it can also do enzymatic work. So we have the RNA to protein set. Then reverse transcriptase comes along and takes us backwards. So now we have the DNA to RNA to protein. We can be a self-replicating system of a cell, like all the cells in your body, like all living things. So that's one hypothesis. A second hypothesis is the protein first hypothesis. And this says that polypeptides were the first of DNA, RNA, or protein. And this says that only after we have the cell membrane in place and we have sophisticated enzymes did DNA and RNA appear, because we would have need the sophisticated enzymes to make the DNA and the RNA. The people who believe this say that RNA is such a complicated molecule that the chances that it just spontaneously formed on its own and was able to sustain is very minimal, so we would have needed the help of enzymes like the protein. And so what would need to happen is proteins arose, then they used their enzymatic properties to make RNA, and that RNA went backwards to DNA, and then they started making the code. So it went totally backwards, protein to RNA to DNA, in the sense of how they arose. But we know that the central dogma is still DNA to RNA to protein. But then once we had all three, then it could go in that order just fine. Then we have the RNA and protein simultaneous hypothesis. And this says that proteins and RNA just appeared at the same time. And it totally gets rid of the question of which came first, because he says they happened at the same time. And so he says that the first cell would have had RNA, which got replicated by proteins, and there you go. That's just how that happened. But most scientists say that that's probably very unlikely due to the fact that the two of them spontaneously appearing at the same time is probably pretty slim, although no one can say that that's not what happened. And then lastly, finally, we get to our DNA, whatever means we get there, whether RNA came first or protein came first, whichever, we have eventually arrived at having this molecule called DNA. So somehow we have to get to the amazing system of DNA to protein that we have right now, the genetic code, the triplet code of amino acids, and how mutations have so little effect, the wobble hypothesis, all of those things. Our genetic code is kind of perfect. Obviously it's not, but it works very, very, very well. And so the fact that it works so well suggests that this genetic code has undergone millions and millions and millions of years of natural selection to get to the almost perfect form that we have it in right now. So there you have it. Those are the 4 steps to get to the living cell. So now we've talked about how life arose, starting with organic monomers. There were no molecules, there were no biotic molecules, no organic molecules, nothing. They had to spontaneously form. Then, without the use of enzymes, they had to be made into organic polymers. our four polymers that we know: proteins, carbohydrates, nucleic acids, and lipids. Then those had to somehow start working together, come together into what we call a protocell. We had to get something that looked kind of like a cell. And then finally that cell had to become alive. It had to be able to sustain life and carry out nutrition and replicate itself using our genetic code. And once we got there, there was the first cell, and then we had our last universal common ancestor, and life took off. And that's section 18.1.